Hello, today we are going to see about acid-base disturbances. The acid-base disturbances include metabolic acidosis, metabolic alkalosis, respiratory acidosis, and respiratory alkalosis. One of the most important formula that you need to know is this formula which is mentioned here, where carbon dioxide combines with water in a reversible reaction which produces bicarbonate ion and H plus. Based upon the changes in values of bicarbonate and H plus, this equilibrium in this equation shifts either to the right or left. Therefore, if you have any loss of bicarbonate, to compensate that loss, the equilibrium will shift to the right, thereby combining more carbon dioxide and water to produce bicarbonate and H plus. In the process of producing more HCO3 minus, the level of H plus will increase above normal, which will cause acidosis. This is the mechanism in which the acid base disturbances occur. Next, we are going to see about the normal values that need to be remembered. The normal pH, PCO2, HCO3 minus, and anion gap should be remembered. The normal pH is 7.35 to 7.45. From this, we can extract the PCO2 values as 35 and 45 respectively. And next, the bicarbonate value is from 22 to 28. We'll get back to that later. And the anion gap is 6 to 12. From 6 to 12, we can extract the bicarbonate values as we can add 10 to the 12 value and we will get a 22, which is the initial lowest level of HCO3 minus, and adding this 6 here we'll get 28, which is the last value of HCO3. Next, we are going to determine whether it is a respiratory or metabolic pathology. Note that this mnemonic can be used only for well compensated acid base disturbances, and inadequately compensated or overcompensated disturbances or mixed acid base disturbances cannot be calculated by using this mnemonic. Differentiate the cause whether it is primarily respiratory or metabolic using the mnemonic ROME. The letters in ROME stands for RO is respiratory opposite, and ME stands for the first two letters and last two letters in metabolic and same. How this goes is that by using the values of pH, PCO2 and HCO3 minus, we can determine whether if there is increase in pH and simultaneously there is increase in PCO2 and HCO3, that is all of them are going in the same direction, that is increasing, then the primary inciting pathology should be metabolic. Whereas if there is increase in pH but PCO2 and HCO3 are decreasing, that is they are going in opposite directions, then the primary inciting pathology is respiratory. Now, how will you identify whether the compensation is adequate or inadequate is using the following formulas. For metabolic acidosis, there is a special formula called Winter's formula, which could be asked in exams, which in metabolic acidosis, the initial inciting event would be change in bicarbonate level, and from that we need to extract the level of PCO2 which indicates adequate compensation. So you, by putting the bicarbonate level in the formula of 1.5 times bicarbonate plus 2 plus 8 plus or minus 2, we can get the estimated PCO2 value as some value plus or minus 2. If the patient's PCO2 value measured is within this range, then there is adequate respiratory compensation for the given metabolic acidosis. Whereas if the PCO2 value is less or high than the estimated level, then there is the compensation is all excessive or inadequate, causing respiratory acidosis or respiratory alkalosis depending upon whether PCO2 is increased or decreased. Similarly, in a case of metabolic alkalosis, just need to add 15 to the bicarbonate level, which gives the adequate PCO2 level for estimation. In case of respiratory acidosis and respiratory alkalosis, there is difference in compensation levels for acute and chronic respectively. As a standard, we will keep the PCO2 levels, which are the inciting events, as increase or decrease in levels of 10, and each increase in 10 of PCO2 should incite increase in one level of bicarbonate in acute state. In that way, if we look at this, in respiratory acidosis, there will be increase in PCO2, and every 10 steps in acute will cause 1 increase in bicarbonate, and every 10 increase will cause 4 increase in bicarbonate in chronic states. Similarly, for respiratory alkalosis, instead of increase in PCO2, there will be decrease in PCO2, and the levels, instead of 1 and 4 in acute and chronic, it will be 2 and 4 in respiratory alkalosis. Next, we'll move on to the causes of metabolic and respiratory acidosis and alkalosis. In metabolic acidosis, the causes can be determined, split into two categories, such as in basis of anion gap. The anion gap is the measure of difference in cations and anions. The cation majority is sodium, whereas the anions are varying in number, mainly chloride and bicarbonate. The remaining anions are organic acids and proteins, which is mentioned here. Organic acids and proteins other than chloride and bicarbonate ion are not measured. Hence, when calculating, there is a gap between the number of sodium and the number of bicarbonate plus chloride, which gives a gap of 6 to 12, which is the normal anion gap. If the anion gap is increased, it causes high anion gap metabolic acidosis. If the anion gap is normal, it causes normal anion gap metabolic acidosis. In high anion gap metabolic acidosis, what happens is that there is loss of bicarbonate, which occurs in a rate such a way that it cannot be exchanged with chloride ion. Therefore, the loss in bicarbonate will be compensated by any other inorganic ion which is entering the bloodstream, which is usually not measured. Therefore, it increases the anion gap. In case of normal anion gap metabolic acidosis, the loss of bicarbonate is compensated by reabsorption of chloride. Therefore, the total anion gap remains the same. Hence, the normal anion gap metabolic acidosis. Now, going for the causes. The high anion gap metabolic acidosis with the mnemonic of mud piles. Most of these conditions which are mentioned here produce an inorganic or organic acid in one way or another, which consumes the bicarbonate and produces anions which are not measured, and thereby increasing the anion gap. The other causes of normal anion gap metabolic acidosis can be remembered with the mnemonic fused car, which is fistula of pancreatic, most of the fistulas, and ureterosigmoidostomy, small bowel fistulas, and diarrhea in which there is loss of bicarbonate and renal tubular acidosis. For cause of metabolic acidosis, we can use the mnemonic lava. And for causes of respiratory acidosis, you can imagine a slow breathing cow, like as a cow as a mnemonic. In respiratory acidosis, what happens is that there is a decreased rate of respiration, thereby CO2 is retained in the body, which produces more acidosis. And in case of respiratory alkalosis, there is excessive respiration which washes out the CO2 and thereby causing alkalosis.